Okay, in our previous video we talked about contrapositive, inverse and converse, right? Now in this video we will try to see another way of creating propositions from another propositions. Okay, now if you remember, previously we talked about conditionals, right? So this video we will talk about biconditional. Okay, so what is biconditional? Now, by definition, if P and Q are two propositions, then the biconditional statement we generally mention it's like this one with both direction arrow. Okay, is the proposition like P if and only if Q. Okay, now this is important, this if and only portion is important over here. Okay, now before we go deeper into that one, let us first try to see what is that its truth table looks like. Okay, now if you see it over here, this P biconditional Q is only true when either both P and Q are true, right? So this time it is true, or both P and Q are false. This time also it is true over here. In rest of the cases it is false over here. Now if you remember for the conditionals, right, now the conditionals was false in this case because when P is true and Q is not happening, that conditional was false in that case. But when P is not happening, we did not bother about whether Q is happening or not. The statement was true over there. But in case of biconditional, this time when P is not happening but Q is happening, this is also false. That means it basically from the truth table it is evident that either P and Q both has to happen. If P is happening, Q has to happen, or if Q is happening, P has to happen, or both should not happen at all. That time only this statement will be true over there, right? So that's why if and only if is important over here, right? So that means if P is happening, Q has to happen. If Q is happening, P has to happen as well. Okay, so that's the main intention behind the biconditional. Okay, now if I just talk about different expressions we have for biconditionals, so these are the different expressions we can have. Like P is the necessary and sufficient condition for Q, right? So if you remember when we talked about the necessary condition and sufficient condition in our conditionals statement video, right, over there we discussed in very detail about what do we mean by necessary condition and what do we mean by sufficient condition. Now as P and Q both has to happen together or they should not happen at all, that's why for biconditionals we are saying P is the necessary and a sufficient condition for Q, right? This could be in this form as well, if P then Q, and also conversely, right, if Q then P. P if Q, this is the short form of if and only if. Okay, or we can write something like this one, P exactly when Q. Okay, so this all of these statements is actually stating the same fact, like it's a biconditional statement. Now if you think through it, okay, now we can derive another expression from here as well, this one, right? So what we are saying a biconditional is nothing but P conditional Q, that means P this right arrow Q and Q right arrow P, Q condition P, right? That means if P is happening, Q has to happen, and if Q is happening, P has to happen. So this could be another form of the biconditional. These two statements are basically equivalent over here. Okay, so let us take a couple of examples over here. Like if you see a statement something like this one, you can take a flight if and only if you buy a ticket, right? Now if we just try to identify the propositions over here, so one of the position could be you can take a flight, right? Now another proposition could be you need to buy a ticket over here, right? Now both of these propositions are actually connected with this clause if and only if. So looks like this is a biconditional statement, right? So if I just give it a name of the first proposition as P and the second proposition as Q, so this is basically a biconditional statement over here, right? Now why it is biconditional? Because if you want to take a flight, you need to buy a ticket over there, right? And if you can't buy a ticket, you cannot take a flight over there, right? So that's why it is a biconditional statement over here. Now in our natural language, sometimes when we speak about biconditionals, we do not mention if and only if explicitly. We generally mention the implicitly part. So we just mention the if part. The other part, like when Q implies P, that part we generally assume it, like we have said, like we already conveyed it. Okay, so similarly, if I just tell this particular statement in our natural language, okay, in our daily language, we may say something like this one: you can take a flight only if you buy a ticket, right? Now this only if construct is our implies construct, right? P implies Q over here, right? Now this is actually a biconditional statement, because you cannot take a flight unless you buy a ticket, right? So when we analyze a particular mathematical statement, right, or if you want to convert a particular statement which used in our daily life to a mathematical statement, you need to assume something or explicitly state something, like, okay, whether this is a biconditional statement or conditional statement. That thing we have to remember over here. Okay, so hopefully this video was helpful. In next video we will talk about more stuff about mathematical logic. Okay, see you in next video.